Welcome to Null Design channel. In today's tutorial I will show you how to create an infinite race animation design concept in Cinema 4D, demonstrated to you now. Together we will deeply explore the process of building the scene geometry from the ground up, using a variety of useful modeling tips and tricks. On top of that, you will learn a practical method for creating endless geometry animation along a closed spline. Let's dive right in. Let's begin by creating a cross-like compound geometry. Add a cube object to the scene and press C to make it editable. Rename it to cross. Extrude it by right mouse click and selecting the extrude tool. Apply the highlighted settings to it. Next, round the corners of the cross geometry by applying a bevel deformer with the highlighted settings. In the Object Manager, right mouse click the cross geometry and select Current State to Object to create a baked cross geometry with the bevels applied. Remove your original cross geometry to keep your Object Manager clean. To proceed further, we need to create closed outline splines that won't intersect with the cross geometry and will serve as track wires for moving geometry along later. Copy the cross geometry and rename it to cross external. Extrude it as demonstrated by configuring the extrusion using the highlighted settings. Using the Loop Pass Cut tool, create 7 evenly distributed cuts along the top part of the cross external geometry. Right mouse click and by selecting the Dissolve tool, remove the selected edge loops as displayed. Repeat this process for the middle and bottom parts of the cross external geometry, and as a result you will get the following outcome. Select all the edge loops shown in the viewport, then right mouse click and choose Edge to Spline tool to transform them into splines. Rename the newly created spline object to splines and change its type field to B-spline. Remove the cross external geometry. Currently each spline in our splines object is open. Its first and last points are not connected. In addition, the first and last points of each spline overlap by sharing the same location in space, as shown in the viewport. We need to fix it. Check the Close Spline field of the splines object to close all individual splines. To remove all excessive overlapping points, select all splines object points, then right mouse click and choose the Optimize tool. Now we need to separate our splines object into individual splines for better control over the upcoming modifications. Select the splines object, go to the top spline menu, choose Segments, then select Explode Segments. Rename the resulting splines as demonstrated and unparent them from the splines object. Remove the splines object. To add thickness to our spline objects and make them look like wires, parent all of them to a connect object. Then parent the connect to a sweep object and add a circle object above the connect, specifying the highlighted radius value. Let's make the cross geometry surface look more organic and less plain than it does now. To do this, we need to increase its polygon density. This can be achieved by parenting it to a remesh object with the highlighted mesh density value. To give the surface a more natural organic look, place a remesh object inside a null, then place a displacer deformer inside the null. Switch to the Shading tab, choose Noise for the shader field and set the noise shader settings as highlighted, or adjust them to your preference for a more unique result. Next, I will show you how to move a geometry object along one of our splines. For the geometry object we will use a tube. Add it to the scene and apply the highlighted settings for its quick configuration. Ensure the height segment's value is high enough to create denser geometry. It is a crucial condition for smooth deformation. Apply Spline Wrap deformer to the tube object. Make sure you are on the Object tab of the Spline Wrap settings, the place where all the magic happens. In the Spline field, drag and drop the spline you would like to use to move our tube geometry along. In my case, I will use Spline 2. Adjust the other settings as highlighted. By changing the offset value, we can move our tube geometry along the spline, referenced in the Spline field. The offset field accepts both positive and negative values, meaning we can move our geometry in any direction. Moreover, the offset value can exceed 100%, allowing us to make our tube geometry complete as many loops along the spline as we wish, and as a result, move it endlessly along the spline. Let's animate the offset field. Set the animated keyframes to the linear type to ensure the tube geometry moves with the consistent speed along the spline it references. Next, copy the tube object. Select the Spline Wrap deformer of the copied tube and adjust its from and to fields by increasing increasing or decreasing them by the same value. In my case, I will increase it by 10%. By doing that, we'll offset the default starting point of the tube's animation by 10% of the length of the spline it references. Ensure that all tubes you animate which reference the same spline have the same movement speed, otherwise they may intersect with each other. By adding more tubes to the scene and experimenting with the size variety, movement speed, movement direction and distribution across different splines, we can create a complex looking animation that will definitely capture attention and bring excitement. That's it for today, all the best and see you in the next tutorial!